Georg Simon Ohm was born on March 16, 1789, in the small city of Erlangen, located in the Holy Roman Empire, which is now part of modern Germany. His birth came during a time of great change in Europe. The late 18th century was a period marked by scientific discovery, political revolution, and social transformation. Although Ohm was not born into a wealthy or highly influential family, his upbringing played a crucial role in shaping his intellectual development and future achievements in science. Ohm's father, Johann Wolfgang Ohm, was a skilled locksmith and metalworker. Despite having little formal education, Johann Wolfgang was a self-taught scholar who had a strong interest in mathematics, science, and philosophy. He believed strongly in education and intellectual discipline, and he taught himself advanced subjects by reading books and studying independently. This love for learning influenced the way he raised his children. Johann Wolfgang took responsibility for educating Georg and his siblings at home, teaching them mathematics, physics, and logical thinking. This home-based education was very rigorous, and it helped Georg develop a strong foundation in scientific thinking from an early age. Georg Ohm's mother, Maria Elizabeth Beck, came from a family of artisans and provided a supportive environment for her children. She encouraged curiosity and discipline, though historical records about her influence are less detailed than those about his father. However, it is clear that Ohm's family valued education and intellectual growth, which was not common for many working-class families during that time. Georg had several siblings, but many of them died at a young age due to illnesses that were common in the 18th century. This was a harsh reality of life during that period, as medical knowledge and health care were limited. These early losses in his family may have influenced Ohm's character, making him more serious, focused, and determined in his studies. When Georg was old enough, he attended the University of Erlangen, where he began formal studies in mathematics and physics. However, his early university education was not entirely smooth. Like many young students, he struggled with discipline and academic focus. He was more interested in social activities and sports than in his studies at first. As a result, he did not perform as well as expected, and his academic progress was slow. His father was disappointed with his lack of seriousness and decided that Georg needed a more disciplined environment to reach his full potential. To improve his education and character, Johann Wolfgang Ohm sent Georg to Switzerland, where he worked as a teacher. This period was a turning point in Georg Ohm's life. Teaching forced him to strengthen his knowledge of mathematics and science, and it helped him develop a more disciplined and responsible attitude. During this time, he realized the importance of education and began to take his studies seriously. After spending some time in Switzerland, Ohm returned to Germany and continued his studies. He eventually earned a doctorate in mathematics from the University of Erlangen. His academic training gave him a deep understanding of mathematical principles, which later became essential in his scientific work. Unlike many scientists of his time, Ohm had a strong mathematical background, and he believed that physical phenomena should be explained using mathematical laws and formulas. This belief later guided his research in electricity. Following his doctorate, Ohm began working as a teacher at various schools and institutions. He taught mathematics and physics at gymnasiums, secondary schools, and technical schools. Teaching was not just a job for him, it was a way to deepen his understanding of scientific concepts. By explaining complex ideas to students, he refined his own knowledge and developed clear and logical thinking. His teaching career also provided him with the opportunity to conduct experiments and research, especially in the field of electricity. During his early teaching years, Ohm faced financial difficulties and professional challenges. Teachers were not highly paid, and scientific research often required expensive equipment. Despite these obstacles, Ohm remained dedicated to his work. He used simple materials and improvised equipment to conduct experiments, showing his creativity and determination. His modest background taught him to be resourceful and persistent, qualities that later helped him make groundbreaking discoveries. Ohm's early education was strongly influenced by the Enlightenment period, which emphasized reason, science, and empirical evidence. Scientists during this era believed that nature could be understood through observation, experimentation, and mathematics. Ohm adopted this scientific approach and applied it to his studies of electricity. He believed that electrical phenomena were not mysterious forces, but natural processes that could be measured and described mathematically. In addition to his formal education, Ohm was influenced by the scientific works of earlier researchers such as Isaac Newton, Leonhard Euler, and André d'Ampère. He studied their writings and learned about their methods of experimentation and mathematical analysis. These influences shaped his scientific thinking and inspired him to search for simple, universal laws in nature. Ohm's early life was not filled with fame or privilege, but it was rich in intellectual training and personal discipline. His father's dedication to education, his experiences as a teacher, and his rigorous academic training laid the foundation for his later discoveries. Without this strong educational background, it is unlikely that Ohm would have been able to formulate the mathematical relationship between voltage, current, and resistance that we now call Ohm's law. In summary, Georg Ohm's early life and education were crucial in shaping him into a great physicist. Born into a modest family, he received a strong home education from his father, faced challenges in his early university years, and later developed discipline through teaching and advanced studies. His education gave him the mathematical skills and scientific mindset that enabled him to make one of the most important discoveries in electrical science. This early period of his life shows that determination, education, and perseverance can lead to extraordinary achievements, even for someone who begins with limited resources. Georg Simon Ohm's early life took place during a time when science was beginning to transform human understanding of nature. Europe in the late 18th and early 19th centuries was influenced by the Enlightenment, a movement that encouraged reason, observation, and scientific inquiry. Although Ohm was born into a modest household, the intellectual environment of the time indirectly influenced his upbringing. His father, Johann Wolfgang Ohm, believed that knowledge was the key to progress, and he was determined to provide his children with an education that went beyond basic schooling. Johann Wolfgang Ohm's role in Georg's education cannot be overstated. Unlike many craftsmen of his time, Johann Wolfgang was deeply interested in academic subjects. He taught himself mathematics and natural philosophy by reading books and studying scientific texts. Because formal schooling was limited and often expensive, Johann Wolfgang decided to personally educate his children. He taught Georg arithmetic, geometry, algebra, and basic physics at home, often using practical examples and logical reasoning. This home education was intense and structured, resembling the curriculum of advanced schools. From a young age, Georg learned how to think logically, solve mathematical problems, and analyze physical phenomena. His father encouraged him to ask questions, observe nature, and seek explanations based on evidence rather than superstition. This approach shaped Georg's scientific mindset and prepared him for future academic studies. The discipline instilled by his father also helped him develop patience and persistence, qualities that would later be essential in his experimental research. However, Georg's early academic journey was not without difficulties. When he entered the University of Erlangen in 1805, he was only 16 years old. At that time, universities were strict institutions with demanding curricula, and students were expected to be highly disciplined. Georg initially struggled to adapt to university life. He was distracted by social activities, sports, and student life, which affected his academic performance. His grades were not impressive, and he did not fully focus on his studies. His father was deeply concerned about this lack of discipline. Believing that Georg needed a change in environment, Johann Wolfgang decided to send him to Switzerland. There, Georg worked as a teacher at a private school. This period marked a turning point in his life. Teaching required him to master mathematical and scientific subjects thoroughly, as he had to explain them to students. This responsibility forced him to study seriously and develop a more mature and disciplined attitude. During his time in Switzerland, Ohm spent long hours studying mathematics and physics. He read scientific textbooks, solved complex problems, and practiced teaching methods. He also developed a passion for clarity and precision in scientific explanations. This experience strengthened his understanding of scientific principles and improved his ability to think critically and logically. After several years in Switzerland, Ohm returned to Germany with a renewed sense of purpose. He resumed his studies and eventually earned a doctorate in mathematics from the University of Erlangen in 1811. His doctoral education provided him with advanced knowledge in mathematical theory, which later became the foundation for his scientific discoveries. Unlike many experimental scientists of his era, Ohm was deeply trained in mathematics, and he believed that nature could be described using mathematical laws. Following his doctorate, Ohm began his career as a teacher at various institutions, including gymnasiums and technical schools. Teaching was not an easy profession at the time. Teachers often faced low salaries, limited resources, and heavy workloads. Despite these challenges, Ohm remained committed to education and research. He believed that teaching and scientific inquiry were closely connected, and he used his teaching experience to deepen his understanding of scientific concepts. Ohm's early teaching positions required him to teach mathematics, physics, and other scientific subjects. This exposure allowed him to explore different areas of science and develop his interests. He was particularly fascinated by electricity, which was still a mysterious and rapidly developing field. Scientists like Alessandro Volta and André Ampère had already made important discoveries, but many aspects of electricity were not yet understood. During this period, Ohm began to conduct experiments in his spare time. Because he did not have access to expensive laboratory equipment, he used simple and improvised tools. He experimented with wires, batteries, and measuring devices to study how electric current behaved in different materials. His modest background taught him to be creative and resourceful, and he learned how to extract meaningful results from simple experiments. Ohm's education was also influenced by the scientific philosophy of the Enlightenment. He believed in empirical evidence, careful measurement, and mathematical analysis. He rejected vague explanations and focused on precise relationships between physical quantities. This scientific approach later led him to discover the relationship between voltage, current, and resistance. In addition to formal education, Ohm was inspired by the works of earlier scientists. He studied Isaac Newton's laws of motion, Leonhard Euler's mathematical theories, and the electrical research of Alessandro Volta and André Marie Ampère. These scientists demonstrated how mathematical equations could describe natural phenomena, and Ohm wanted to apply the same approach to electricity. Despite his growing knowledge and dedication, Ohm faced many struggles during his early career. He often moved between teaching positions, searching for better opportunities. His financial situation was unstable, and he sometimes felt frustrated by the lack of recognition for his work. However, these hardships strengthened his determination to contribute to science. Ohm's early life and education taught him several important lessons. He learned the value of discipline, persistence, and curiosity. He experienced failure and distraction in his early university years, but he transformed these challenges into motivation. His father's emphasis on education, his teaching experiences in Switzerland, and his advanced mathematical training all played a crucial role in shaping his scientific career. By the time Ohm began his groundbreaking research in electricity, he had already developed a strong foundation in mathematics, physics, and scientific reasoning. His early life prepared him to approach scientific problems systematically and logically. Without this educational background, he would not have been able to formulate Ohm's law, one of the most fundamental principles in electrical science. In conclusion, Georg Ohm's early life and education were marked by modest beginnings, strong parental guidance, academic struggles, and intellectual growth. His father's self-taught knowledge and dedication to education gave him a strong foundation. His experiences as a student and teacher shaped his discipline and scientific thinking. Through perseverance and rigorous study, Ohm transformed himself from a distracted student into a pioneering physicist, whose work continues to influence modern technology. His early life shows that education, determination, and passion for knowledge can lead to discoveries that change the world. Georg Simon Ohm's interest in physics and mathematics did not develop suddenly. Instead, it grew gradually through his upbringing, education, and life experiences. From an early age, Ohm was exposed to mathematical and scientific thinking, which shaped his intellectual curiosity and guided him toward a lifelong dedication to scientific research. His passion for these subjects became the foundation of his later discoveries, especially his groundbreaking work in electricity. Ohm's interest in mathematics began in childhood, largely influenced by his father, Johann Wolfgang Ohm. His father was not formally educated in universities, but he was a deeply self-taught man who studied mathematics, physics, and philosophy independently. He believed that mathematics was the key to understanding the natural world, and that logical thinking was essential for intellectual development. As a result, he taught Georg mathematics at home using books, problem-solving exercises, and logical reasoning methods. From a young age, Georg learned arithmetic, geometry, algebra, and basic principles of physics. His father encouraged him to solve mathematical problems and to understand the logic behind formulas rather than memorizing them. This method of learning helped Georg develop analytical thinking skills and a strong appreciation for mathematical structure and order. Mathematics was not just a school subject for him. It became a way of thinking and interpreting the world. As Georg grew older, his curiosity expanded beyond basic mathematics. He began to study advanced topics such as calculus, trigonometry, and mathematical physics. These subjects fascinated him because they provided tools to describe physical phenomena in precise terms. He realized that mathematics could explain motion, forces, and natural laws in a clear and systematic way. This realization deeply influenced his future scientific approach. When Ohm entered the University of Erlangen, he formally studied mathematics and physics. Although he initially struggled with discipline and focus, his exposure to university-level science strengthened his interest in these subjects. University courses introduced him to classical mechanics, geometry, and the works of famous scientists such as Isaac Newton and Leonhard Euler. These scientists demonstrated how mathematical equations could describe the laws of nature, and Ohm admired their ability to connect theory with observation. However, Ohm's early university years were not entirely dedicated to academic excellence. He was distracted by student life and sports, which affected his academic performance. Despite this, his underlying interest in mathematics and physics never disappeared. His father's disappointment and decision to send him to Switzerland became a turning point. Teaching mathematics and science in Switzerland forced Ohm to deepen his understanding of these subjects, and he began to study them with greater seriousness and dedication. During his time in Switzerland, Ohm developed a strong passion for teaching mathematics and physics. Teaching required him to explain complex concepts in a simple and clear way, which improved his own understanding. He realized that mathematics and physics were not just abstract subjects, but practical tools for understanding the world. This teaching experience strengthened his interest in scientific inquiry and motivated him to pursue further research. After returning to Germany, Ohm continued his studies and earned a doctorate in mathematics. His doctoral research further deepened his knowledge of mathematical theory. He studied advanced mathematical concepts such as differential equations, analytical geometry, and mathematical modeling. These subjects later became crucial in his electrical research, where he used mathematical formulas to describe the behavior of electric circuits. Ohm believed strongly that physics should be explained using mathematics. At a time when many scientists relied on qualitative descriptions and philosophical explanations, Ohm insisted on quantitative measurement and mathematical relationships. He believed that nature followed precise laws that could be expressed in equations. This belief was influenced by the scientific tradition of Newtonian physics, which emphasized mathematical laws of motion and universal gravitation. Ohm's interest in physics was also influenced by the rapid scientific developments of his time. The late 18th and early 19th centuries were periods of great discovery in physics. Scientists such as Alessandro Volta had invented the electric battery, André Ampère had studied electromagnetism, and Jean-Baptiste Biot and Félix Savart had investigated magnetic fields. These discoveries fascinated Ohm and inspired him to explore the field of electricity. Electricity was a mysterious and exciting subject during Ohm's lifetime. Many scientists were experimenting with electrical currents, but the underlying laws were not fully understood. Ohm saw an opportunity to apply mathematics to this new field and uncover its fundamental principles. His interest in physics and mathematics combined, leading him to focus on electrical phenomena. Ohm's mathematical mindset influenced the way he conducted experiments. He did not simply observe electrical effects. He measured them carefully and analyzed the data mathematically. He believed that experimental results should be expressed in numerical terms and mathematical formulas. This approach was innovative at the time and helped him discover the relationship between voltage, current, and resistance. In addition to electricity, Ohm was interested in acoustics, optics, and thermodynamics. He studied how sound waves behave, how light travels, and how heat is transferred. His broad interest in physics reflected his belief that all natural phenomena could be understood through scientific laws and mathematical relationships. He published several papers and books on various topics, demonstrating his versatility as a scientist. Ohm's passion for mathematics also influenced his teaching methods. He emphasized logical reasoning, problem solving, and mathematical proof in his classes. He encouraged students to think critically and to use mathematics as a tool for understanding physics. His teaching style reflected his belief that mathematics was the language of science. Despite his deep interest in mathematics and physics, Ohm faced many challenges. He lacked financial resources and had limited access to advanced laboratory equipment. Many scientists of his time worked in well-funded universities or research institutions, but Ohm often conducted experiments with simple materials. However, his strong mathematical knowledge allowed him to extract meaningful results even from simple experiments. Ohm's interest in mathematics also helped him communicate his discoveries effectively. When he formulated Ohm's law, he expressed it in a simple mathematical equation: V equals I times R. This equation clearly described the relationship between voltage, current, and resistance. His ability to express physical laws mathematically made his work understandable and useful for other scientists and engineers. Ohm's dedication to physics and mathematics was not only intellectual but also philosophical. He believed that science should be based on rational thinking, measurement, and mathematical description. He rejected mystical explanations and focused on empirical evidence. This scientific philosophy guided his research and influenced his contributions to physics. In summary, Georg Ohm's interest in physics and mathematics was a lifelong passion that began in childhood, developed through education, and matured through teaching and research. His father's home education, university studies, teaching experiences, and exposure to scientific discoveries all contributed to his deep fascination with these subjects. His belief in mathematical laws and scientific reasoning led him to apply mathematics to electricity, resulting in one of the most important discoveries in modern science. His interest in physics and mathematics not only shaped his career, but also laid the foundation for modern electrical engineering and technology. Georg Simon Ohm's fascination with physics and mathematics was not just an academic preference. It was a deep intellectual passion that shaped his identity as a scientist. Throughout his life, he believed that mathematics was the language through which nature expressed its laws, and physics was the science that revealed how those laws governed the physical world. This belief guided his research, teaching, and scientific philosophy. One of the most important influences on Ohm's interest in mathematics was the scientific tradition of the Enlightenment. The Enlightenment emphasized reason, logic, and scientific investigation as the primary ways to understand the universe. Thinkers such as Isaac Newton, René Descartes, and Gottfried Wilhelm Leibniz had demonstrated that natural phenomena could be explained using mathematical equations and logical reasoning. Ohm admired these thinkers and sought to follow their approach in his own work. During his academic training, Ohm studied the works of Newton and Euler in detail. Newton's laws of motion and universal gravitation showed how mathematical equations could describe physical reality with remarkable precision. Euler's contributions to mathematics, especially in calculus and analytical mechanics, demonstrated the power of mathematical modeling. These scientists inspired Ohm to believe that electricity, like motion and gravity, must follow mathematical laws. Ohm's mathematical education gave him a unique advantage over many of his contemporaries. At the time, many experimental scientists focused on qualitative observations rather than precise measurements. Ohm, however, believed that scientific knowledge must be quantitative. He insisted on measuring electrical quantities such as voltage and current and expressing their relationships in mathematical form. This quantitative approach was crucial in his later discovery of Ohm's law. As a teacher, Ohm further developed his interest in mathematics and physics. Teaching required him to break down complex ideas into understandable concepts, which sharpened his analytical skills. He taught geometry, algebra, trigonometry, and physics to students at gymnasiums and technical schools. Explaining these subjects reinforced his own understanding and allowed him to explore deeper theoretical questions. Ohm also used teaching as an opportunity to experiment with scientific instruments and demonstrations. He designed experiments to show physical principles to students, such as the behavior of electric currents, the properties of sound waves, and the laws of mechanics. These classroom experiments often inspired him to conduct more detailed scientific research on his own. His interest in physics extended beyond electricity. Ohm studied acoustics, the science of sound, and published research on how sound waves propagate and how the human ear perceives sound. He also studied optics, investigating how light travels and how lenses and mirrors affect light. In thermodynamics, he explored the behavior of heat and its relationship to physical systems. This broad interest in physics reflected his belief that all natural phenomena were governed by universal laws. However, electricity remained his primary passion. The early 19th century was a time of rapid discovery in electrical science. Alessandro Volta had invented the voltaic pile, the first reliable electric battery, which allowed scientists to study continuous electric currents. Andremer Ampère had discovered the relationship between electricity and magnetism. These discoveries fascinated Ohm, and he wanted to understand the underlying principles of electrical conduction. Ohm's mathematical mindset led him to approach electricity differently from other scientists. Instead of focusing only on experimental observations, he sought mathematical relationships between electrical quantities. He measured the current flowing through wires of different lengths, thicknesses, and materials. He varied the voltage using batteries and measured the resulting current. He then analyzed the data mathematically, searching for patterns and relationships. Through these experiments, Ohm discovered that the current flowing through a conductor is directly proportional to the voltage and inversely proportional to the resistance. He expressed this relationship in a simple mathematical formula, V equals I times R. This equation became known as Ohm's law and is now one of the fundamental principles of electrical engineering. Ohm's interest in mathematics was essential for this discovery. Without his strong mathematical training, he might not have recognized the linear relationship between voltage and current or understood how resistance affected current flow. His ability to translate experimental data into mathematical equations was what set him apart from many other researchers of his time. Despite his scientific achievements, Ohm's work was not immediately recognized. Some scientists criticized his reliance on mathematics, arguing that electrical phenomena were too complex to be described by simple equations. Others doubted the accuracy of his measurements. However, Ohm remained confident in his mathematical approach. He believed that scientific truth would eventually be confirmed through repeated experiments and logical reasoning. Over time, other scientists confirmed Ohm's findings, and his law became widely accepted. His mathematical approach influenced future scientists and engineers, who used equations to design electrical circuits, power systems, and electronic devices. Ohm's work demonstrated the power of mathematics in physics and helped establish electrical engineering as a scientific discipline. Ohm's philosophical view of science was deeply connected to his interest in mathematics and physics. He believed that nature was governed by universal laws that could be discovered through observation, experimentation, and mathematical analysis. He rejected speculative theories that lacked empirical evidence and mathematical support. This scientific philosophy aligned with the principles of modern science. In addition to his research, Ohm wrote textbooks and scientific papers on mathematics and physics. His writings emphasized clarity, precision, and logical reasoning. He wanted students and scientists to understand not only the results of scientific research, but also the methods used to obtain those results. His textbooks helped spread mathematical and scientific knowledge to future generations. Ohm's dedication to mathematics and physics also influenced his personal life. He spent much of his time studying, teaching, and experimenting. He lived a relatively modest and quiet life, focused on intellectual pursuits rather than social activities. His commitment to science was driven by curiosity and a desire to understand the natural world. In conclusion, Georg Ohm's interest in physics and mathematics was the driving force behind his scientific career. From childhood education to university studies, from teaching to experimental research, mathematics and physics shaped his thinking and guided his discoveries. His belief in mathematical laws, his quantitative approach to science, and his passion for understanding nature led him to formulate Ohm's law, one of the most important principles in modern science. Ohm's life shows that deep interest, disciplined study, and scientific curiosity can lead to discoveries that transform technology and human knowledge. Georg Ohm's experiments with electricity and circuits were the foundation of his greatest scientific achievement, Ohm's law. During the early 19th century, electricity was still a mysterious phenomenon. Scientists had discovered batteries and electrical currents, but they did not fully understand how electricity behaved in wires and circuits. Ohm was determined to study electricity in a systematic and scientific way, using careful experiments and mathematical analysis. Ohm began his research while working as a teacher. Because he did not have access to advanced laboratories, he used simple and inexpensive materials. He used metal wires of different lengths, thicknesses, and materials such as copper and iron. He connected these wires to batteries, known at the time as voltaic piles, which produced electric current. He also used early measuring instruments to measure the flow of current and the voltage applied to the circuit. One of Ohm's main goals was to understand how resistance affected electric current. Resistance is the property of a material that opposes the flow of electric current. Ohm observed that when he used longer wires or thinner wires, the current became weaker. When he used shorter or thicker wires, the current increased. He also noticed that different materials conducted electricity differently. These observations led him to believe that resistance played a key role in controlling the flow of electricity. Ohm carefully recorded his experimental results and analyzed them mathematically. He changed one factor at a time, such as wire length or voltage, and observed how the current changed. This method allowed him to identify clear patterns. After many experiments, he discovered that the current flowing through a circuit was directly proportional to the voltage and inversely proportional to the resistance. In simple words, increasing voltage increases current, while increasing resistance decreases current. He expressed this relationship in a mathematical equation, V equals I times R, where V is voltage, I is current, and R is resistance. This equation became known as Ohm's law. It was one of the first precise mathematical laws in electrical science, and provided a simple way to predict how electrical circuits behave. At first, many scientists doubted Ohm's results. Some believed his experiments were inaccurate, and others thought electricity was too complex to be described by a simple formula. However, as more scientists repeated his experiments, they confirmed his findings. Eventually, Ohm's law became a fundamental principle in physics and electrical engineering. Ohm's experiments with electricity and circuits were revolutionary because they transformed electricity from a mysterious phenomenon into a measurable and predictable science. Today, engineers and scientists use Ohm's law to design electrical circuits, power systems, and electronic devices. His careful experiments and logical analysis laid the foundation for modern electrical technology and changed the way we understand electricity. The discovery of Ohm's law is one of the most important milestones in the history of physics and electrical science. Georg Simon Ohm, a German physicist, discovered this law in the early 19th century through careful experiments and mathematical analysis. At that time, electricity was still a new and poorly understood field. Scientists knew that electric current could flow through wires and circuits, but they did not understand the exact relationship between voltage, current, and resistance. Ohm's work helped explain this relationship clearly and scientifically. Ohm conducted many experiments using simple electrical circuits made of batteries, wires, and measuring devices. He used wires of different lengths, thicknesses, and materials to see how they affected the flow of electric current. He also varied the voltage produced by batteries to observe how current changed. By measuring these changes, Ohm collected a large amount of data about how electricity behaved in different conditions. Through his experiments, Ohm noticed a consistent pattern. When he increased the voltage, the current increased proportionally. When he increased the resistance by using longer or thinner wires, the current decreased. These observations led him to conclude that there was a mathematical relationship between voltage, current, and resistance. He discovered that the current flowing through a conductor is directly proportional to the voltage and inversely proportional to the resistance. Ohm expressed this relationship in a simple mathematical equation. V equals I times R, where V represents voltage, I represents electric current, and R represents resistance. This equation became known as Ohm's law. It allows scientists and engineers to calculate how much current will flow in a circuit if they know the voltage and resistance, or to find resistance if they know voltage and current. When Ohm first published his findings in 1827, his work was not widely accepted. Some scientists doubted his experiments and believed that electricity was too complex to be explained by such a simple formula. Others criticized his use of mathematics in describing electrical phenomena. Despite this criticism, Ohm continued to defend his work and believed strongly in his results. Over time, other scientists repeated Ohm's experiments and confirmed his findings. As electrical science developed, Ohm's law proved to be accurate and extremely useful. It became one of the fundamental laws of physics and the basis of electrical engineering. Today, Ohm's law is taught in schools and universities around the world and is used in designing electrical circuits, electronic devices, and power systems. In conclusion, the discovery of Ohm's law transformed our understanding of electricity. Georg Ohm's careful experiments and mathematical approach turned electricity from a mysterious force into a predictable and measurable science. His discovery continues to play a crucial role in modern technology and scientific research. When Georg Simon Ohm first published his research on electricity, his work was not immediately accepted by the scientific community. In 1827, he published his major book Die galvanische Kette, mathematische Bearbeitet, the galvanic circuit investigated mathematically, in which he explained the relationship between voltage, current, and resistance using mathematical equations. Today, this relationship is known as Ohm's law, but at that time, many scientists were skeptical and critical of his findings. One reason for the initial rejection of Ohm's work was that electricity was still a very new and complex field. Many scientists believed that electrical phenomena were too complicated to be explained by a simple mathematical formula. They were not used to applying mathematics so strictly to experimental physics, and some preferred qualitative descriptions rather than precise measurements and equations. Ohm's strong reliance on mathematics made his work difficult for some scientists to understand and accept. Another reason for the criticism was Ohm's modest background and position. Unlike some famous scientists who worked in prestigious universities and research institutions, Ohm was a schoolteacher with limited resources. He conducted his experiments using simple equipment, and some scientists doubted the accuracy of his measurements. Because he did not belong to the scientific elite, his work did not receive immediate attention or respect. As a result of this rejection, Ohm faced professional difficulties. He struggled to find stable academic positions and felt discouraged by the lack of recognition. However, he remained confident in his research and continued to defend his findings. He believed that scientific truth would eventually be recognized through repeated experiments and logical reasoning. Over time, other scientists repeated Ohm's experiments and confirmed his results. As electrical science advanced, researchers realized that Ohm's law accurately described how electrical circuits behave. His work proved to be extremely useful for understanding and designing electrical systems. Gradually, the scientific community began to accept and appreciate his contributions. In the later years of his life, Ohm finally received the recognition he deserved. He was awarded prestigious honors, including the Copley Medal from the Royal Society in 1841, one of the highest scientific awards of the time. He was also appointed to important academic positions, including a professorship at the University of Munich. His work became widely taught and respected in scientific institutions across Europe. Today, Georg Ohm is remembered as one of the pioneers of electrical science. Ohm's law is a fundamental principle in physics and electrical engineering, and the unit of electrical resistance is named the Ohm omega in his honor. His journey from rejection to recognition shows the importance of persistence, confidence, and dedication in scientific research. Ohm's story reminds us that groundbreaking discoveries may not be immediately accepted, but true scientific contributions eventually gain recognition and change the world. Georg Simon Ohm made significant contributions to both science and education. He is best known for discovering Ohm's law, but his impact goes beyond this single discovery. Through his scientific research and dedication to teaching, Ohm helped shape modern physics and electrical engineering and influenced generations of students and scientists. Ohm's most important scientific contribution is Ohm's law, which describes the relationship between voltage, current, and resistance in an electrical circuit. This law, expressed as V equals I times R, became a fundamental principle in physics and engineering. It allows scientists and engineers to calculate how electricity flows in circuits and to design electrical systems safely and efficiently. Today, Ohm's law is used in everything from simple classroom experiments to complex electronic devices, power grids, and communication systems. In addition to his work on electricity, Ohm contributed to other areas of physics. He studied acoustics, the science of sound, and investigated how sound waves travel and how the human ear perceives sound. He also explored topics in optics, light, and thermodynamics, heat. Although these studies are less famous than his work on electricity, they showed his broad scientific interests and his desire to understand the laws of nature through mathematics and experimentation. Ohm also wrote several scientific books and papers. His most famous book, The Galvanic Circuit Investigated Mathematically, presented his experiments and explained electrical phenomena using mathematical equations. This book was one of the earliest examples of applying mathematics systematically to electrical science. His writings helped establish a scientific approach to studying electricity and inspired future researchers to use precise measurements and mathematical models. As a teacher, Ohm played an important role in education. He taught mathematics and physics at secondary schools and technical institutions. Teaching was not just his profession, it was part of his scientific mission. He believed that students should understand the logical and mathematical foundations of science, not just memorize facts. His teaching style emphasized problem solving, clear explanations, and critical thinking. Ohm used experiments and demonstrations in his classes to help students understand physical principles. He believed that practical experiments were essential for learning science. By combining theory with hands-on demonstrations, he helped students develop a deeper understanding of physics and mathematics. Despite facing financial difficulties and lack of recognition early in his career, Ohm remained dedicated to teaching and research. Later in life, he became a professor at the University of Munich, where he continued teaching and conducting research. His influence as a teacher helped spread scientific knowledge and inspired students to pursue careers in science and engineering. In conclusion, Georg Ohm's contributions to science and teaching were profound and long-lasting. His discovery of Ohm's law revolutionized electrical science. His research advanced multiple fields of physics, and his dedication to education helped shape future generations of scientists. Ohm's work continues to influence modern technology and scientific learning, making him one of the most important figures in the history of physics. Georg Simon Ohm's legacy in modern electrical engineering is immense and continues to influence technology, education, and scientific research today. His discovery of Ohm's law provided a clear and simple way to understand how electricity behaves in circuits. This law became one of the fundamental principles on which modern electrical engineering is built, and it is still used by engineers, scientists, and students around the world. Ohm's law, expressed as V equals I times R, explains the relationship between voltage, current, and resistance. This simple equation allows engineers to predict how electrical circuits will behave under different conditions. For example, it helps engineers calculate how much current will flow through a circuit, how much resistance is needed to protect devices, and how much voltage is required to power electrical systems. Without this basic understanding, designing safe and efficient electrical devices would be extremely difficult. In modern electrical engineering, Ohm's law is used in the design of electronic circuits, power systems, communication devices, and computer hardware. Engineers use it to design resistors, amplifiers, power supplies, and integrated circuits. It is also essential in understanding how batteries, motors, generators, and transformers work. Every time an engineer calculates the resistance of a wire or the current in a circuit, they are using Ohm's principles. Ohm's legacy is also evident in electrical education. Ohm's law is one of the first concepts taught in physics and engineering classes. Students learn it to understand basic circuit theory and electrical measurements. It serves as a foundation for more advanced topics such as Kirchhoff's laws, semiconductor theory, and digital electronics. By learning Ohm's law, students gain a fundamental understanding of how electricity works, which is essential for careers in engineering and technology. In honor of Georg Ohm, the unit of electrical resistance is named the Ohm omega. This international unit is used in scientific measurements, engineering designs, and everyday electronic devices. Naming the unit after him shows how important his contribution is to science. Every time engineers measure resistance in ohms, they are remembering his work. Ohm's approach to science also left a lasting legacy. He emphasized careful experimentation, precise measurement, and mathematical analysis. His method of combining theory with experiment influenced modern scientific research. Electrical engineers today follow the same approach. They use mathematical models, simulations, and experiments to design and improve electrical systems. Furthermore, Ohm's work helped transform electricity from a mysterious phenomenon into a predictable and controllable science. Before Ohm, electricity was largely experimental and poorly understood. After his discovery, engineers could design electrical systems with confidence and accuracy. This shift laid the foundation for the development of electrical power grids, telecommunications, computers, and modern electronics. In conclusion, Georg Ohm's lasting legacy in modern electrical engineering is his fundamental law, his influence on scientific methodology, and his impact on education and technology. His discoveries continue to shape the world of electronics, power systems, and communication. Ohm's work proves that a single scientific discovery can have a lasting impact on human progress and technological advancement.